All right, everyone, welcome back. So today we're going to talk about 5.3. So I referenced this in the last lesson, but now that we know what congruent polygons are, we're going to focus our effort in the next few sections on triangles and specifically how do I prove them congruent. So the main idea from the last lesson is that we said two figures, whether it's a triangle, quadrilateral, whatever, are congruent if all the corresponding parts are congruent. So all the sides and all the angles. So for a triangle, that means we have three sides and three angles. So if we had all three sides congruent and all three angles congruent, then we can conclude that the triangles are in fact congruent. But that's very tedious, right? That's six different things we need to prove. So the question is, do we need all six? And the answer is going to be no, that's too much work. So we're going to come up with um, shortcuts to prove triangles congruent. So we're going to have a list of five of them total. There's only four here, but we don't have to worry about all that because in this section, we're just going to talk about something called SAS, and that's the title of the section. So 5.3, we're going to prove triangles congruent using SAS. So let's start by talking about exactly what that means. Um, okay, so we need sides and angles, right? Three sides, three angles. So the S stands for sides, the A stand for angles. So we need two side, angle side is what's going to stand for. So we need two sides and an angle. So basically, what this means is if I have a triangle, so let's say I have this triangle here. Okay, so to make a congruent triangle, I don't need all three sides and all three angles. So if I just take two sides, so for example, you can see I took the two labeled sides here, so this left side and this right side, and this angle. And notice the angle I chose, it's the angle where the two sides meet. So if I just take the sides and the angles, you can see here, there's only one physical triangle I can make. There's only one way I can connect this point to this point. So if I take everything here, you could see that in fact, there's no other way the triangle would fit, no matter where I move it. The only position it could be in is there. So these are, in fact, the same exact shape, as you can see, in the same exact size. And it doesn't matter what size the triangle is. If I change the shape of it, if I change the size of it, make it big or small, you could see with just the two sides and this angle in between them, I do, in fact, have a congruent triangle because there's only one physical way you can connect the two vertices over here. So this is going to be our first shortcut formula. If I have just the two sides, and once again, notice the position of the angle. Even in the title here, angle is between the two sides. Um, Even the A here, it's between the two S's. So this isn't the same as like SSA or the A has to be in the middle basically. So if two sides and the included, and we're going to talk about that before we practice with this. That's the key word here. So two sides and the angle between the two sides. So the included angle is going to be where the two sides meet. So if I have this side and this side, you can see the two sides meet right here. So two sides in the included angle are congruent to two sides in the included angle of another triangle, then we can prove that these two triangles are in fact congruent. Because as we said, there's only one other way to connect those two vertices there. So if I just had this three, and three is a lot simpler than six, right? It's less tedious. So if I had these two sides and the angle between them, so A and D are the two angles where the two sides meet. So here it would be D. Then we can in fact conclude that the triangles are congruent. And our reason, you don't have to write side angle side theorem. You could just write SAS when we'll look at proofs at the end here. So side angle side is going to be our reason for that. So before we actually practice with this, so if I have two sides and the angle between them, let's talk about that angle between the two sides because it has to be the included angle, as I mentioned. So just practice naming the included angle. So the angle between the two sides. So you could even like highlight it with your pencil. So if I have this side in here and this side here, it should be obvious just if I highlight the two sides where the two red lines meet. So this would be here. So angle G would be the included angle for this one. Okay, and you could also tell, actually, let's go through the rest of here. So if I look at these two sides, if I have this side and this side, the two red lines meet at I. So for the second one, I would be the included angle. And for this one, what you might notice is if you look at the names of the sides, like for this one, for example, this side is IH. Okay, and then this side is IG. Okay, and so the included angle will always be whatever letter they share because the two sides that make up the angle will have to have the same letter in it. So you can see here I is the shared letter. So if you look at just the names of the sides, it's easy to tell even without the diagram what the included angle would be. It's whatever letter is shared. So if I look at this one, this is IH, and then this is GH. So if you ask yourself what letter is in both of these names, the H, right? So angle H would be the included angle. And you can physically see that's where the two meet. But as I said, you don't even need the diagram, so you have to copy this next one down. But if even without the diagram here, if I look at these two, E is the repeated letter. So angle E would be included angle. Here, the S repeats, SS. So in the second one, S is the included angle. And you could even tell like ES and YS. So ES is here, YS is here. So the two sides meet right here. So this angle would be in between the included angle. And here, the Y repeats, so angle Y. So diagram or not, you can just look at the names of the sides. The in-between angle will be whatever letter repeats in both of the side names. All right, so I want to practice with, we're going to mainly focus on proofs, but just stating whether we can prove the two triangles are congruent. Okay, so as I said, we're going to have five in our toolbox altogether, five shortcuts we can use, but right now the only thing we have in our toolbox is SAS. So it's either that or no, unless we have all six parts, obviously, by definition. But if I look at these two triangles here, we can see I do have one side here. So one side, well, one pair of sides congruent. We do have the right angle, and we know all right angles are congruent, right? This is 90 and this is 90, so that's congruent as well. And what I also notice, if I look at these two triangles, so this triangle here, I'll do that one in red. And if I look at this one in blue, they do share a side. So the red and blue, they have this side in between them. So this side is highlighted both red and blue. Okay, so if I have a shared side, and we did this a little bit in the last lesson, I like putting an X there because it's congruent to itself. Remember, if something is congruent to itself, what property is that? That's the reflexive property, right? So we do have, bring my marker back, we do have this shared side. So this side is in both. So if it's 10 inches in the top triangle, it'll be 10 inches in the bottom triangle. So it's the same. So we do have two sides, and this is the angle in between the two sides, right? So it's where the two sides meet. So this one would be a yes. Okay, for this one, we do, once again, the top and the bottom do share a side. So we do have this shared side here. So if I look at this top triangle, we have a side, and then this is, in fact, the angle between them. So we do have SAS here. If I look at the bottom triangle, well, we have the reflexive side here, or the side congruent to itself, and then the side that's marked is here. So the included angle would be the two sides meet here. So we don't have the included angle, right? We have, that's a bad word, but SSA, which is not in our toolbox. So since it's not the included angle, this one is going to be a no. Okay, if I look at the next one here, we do have a shared side once again. So if you ask yourself here, are these congruent? We do, in fact, two sides and the angle between them. And here we have two sides and once again, the angle between them. So we have two sides and the angle between them. So these two would have to be congruent. Okay, what do we think about this next one? So it looks good in the left. We have two sides and the angle between them. But in this one, the two sides we have are here and here. So the included angle would be where they meet, which would be here, which we do not have. So this is also going to be a no. So number 4 will be a no. Okay, let's look at a few more. So for this one, we do have the shared side. So I can label that. Okay, so here we have two sides and the included angle. And here we have two sides and the included angle. So we do, in fact, have side angle side. Number 6, we do have a reflexive side. So if I label that, just by looking at this bottom one, if I have this side and then the shared side here, this included angle here is not marked. So since I do not have this included angle, this one is going to be a no. Okay, and what do we think about this bottom one? So your answer should have been yes. We do have two sides, and right angles are always congruent, so that one should be a yes as well. Okay, and just to point out, you don't only need side angle side. You could have multiple, like you could have all, obviously all six is the definition, but even if you have extra stuff, as long as you have two sides and the angle between them, you are good to go. So I notice here I have this side and this side. Okay, and I also have these two pieces. So I don't have the entire side because if I look at this triangle here, the side of this triangle is this entire bottom blue one, right? So this is just a piece of it. But what you'll notice, and if I highlight this triangle as well, right? So if we have these two congruent pieces, so here and then here, right? So whatever this is, let's say just like, I don't know, x equals x. So both of those are the same. Notice we're adding on the same piece in the middle to both of them. So to get the blue side, I take my congruent piece plus middle. To get my red side, I take the red piece plus the middle. So remember, I could add on, so if I call the middle y, whatever it is, I could add on the same thing to both sides, right? So if I add on y to both sides, our addition property tells me that these are still congruent, right? So if I add on 2 to both sides, it's still congruent. So we do know, in fact, that these entire bottom sides are congruent here because we're adding on the same piece to each of them to get the entire side. And if I add on the same piece to both sides and they're equal, which they are, we have the congruent marks here, um, they'll be congruent. Okay, so if I look at these two sides, so I notice this side and this side, the included angle would be here, which we don't have marked. Okay, and same thing here. So this side and this side, these two sides meet here. So the included angle would be in fact here. So if it's not marked, that doesn't necessarily mean this is going to be a no because notice the other two angles are marked, right? And in the last section, we went over our third angles theorem. So if we have two angles of a triangle congruent, that forces the third one to be congruent. Remember, because if these two are, I don't know, like 90 and 60, so like 150. So if we have 150 degrees here, that forces this one to be 30. If this is 150, this forces it to be 30 because it needs 180. So by our third angles theorem, we can in fact prove, we already have a single arc, so I'll do a double. We can in fact prove that these two are congruent. So it takes a few of our properties, but if we do have two sides and the included angle by our third angles theorem, this one would be a yes. So sometimes it's not obvious just by looking at it. Sometimes you might need to use some properties. This one's definitely a bit of a trickier one, but as long as you're able to get that side angle side, you can in fact use it. Okay, one other thing I want to talk about before we get to some algebra ones and proofs is we'll be doing this, or you'll be doing this a lot in this chapter, is what additional information do you need to prove that the triangles are congruent? Because you notice all I have is one marking here. So, and we need three things. We need side, side, and the angle between them. Okay, so we do have this side here. So we have one side. And if you look at these two triangles, if you ask yourself, do I know just by looking at it any other pieces are congruent? So just by looking at this, you should notice we do in fact have an X here. So we do have vertical angles here, right? We have our vertical angles theorem, VAT. So we know that these are congruent. So we do have the angle. Okay, so if it asks what additional piece do I need? Well, we need a side, but not just any side. We need the side that, the other side that would make the angle the included one, right? So if I have this side here, well, that's the right side of the angle. So for this to be the included angle, I need the left side of the angle. So I would need this side here. So it looks like we need JI. So if I knew that JI was congruent to, so if I have this side here, so if I have this vertical angle here, the other side of the angle would be here. So it looks like IE. Okay, so if I knew that JI and IE were congruent, that would allow me to use side, the vertical angles. And if we knew this additional piece here, if this were the case, then we would have side, angle, side, and we would have all three pieces. So that's the piece we need, that side, that includes the angle. Okay, so just stating what additional information you need. So you always want to look for vertical angles, or in the last one, third angles theorem. So different things that would come up. Okay, so let's go ahead and look at an algebra one. I'm going to skip number 10 just for time. But if I look at this problem, I'm going to switch over. So just to write a little neater here. Okay, so if I look at this one, let me go back to the PowerPoint. It says, find the values of X and Y using the information in the diagram. So if I look at these two triangles here, once again, I don't have every single piece labeled, but I do have this side with the marks here, and the angle between them. So we do have side, angle, side. So I do have side, angle, side. for both of the triangles. So I do know that these two triangles are congruent, which means all the corresponding pieces are congruent. So one thing that might help us before we just go ahead and solve for x and y is to write a congruent statement. So remember, if I write a congruent statement, I need to have all the letters in the correct position, right? So if I look at this triangle here, I'll start with only one angle is labeled, so B. So I'll start with that one. So if I have triangle B, so I'm going to start with the marked angle and I'm going to go across the side with a single tick mark on it. Okay, so I could say B, A, C. Okay, so that triangle would be congruent to, so if I start with the one second, I started with the marked angle, so I'm going to start with E here. And we went across the side that with the single tick mark on it, right? So to name this one, I'm going to start at E. And if I go along the side with the single tick mark on it, we're going to go E, F, D. So I want to make sure all the corresponding letters are in the correct position here. Okay, so it says to solve for x and y, so it doesn't really matter which one we do first. So if I look at x, the only x I see is here, so this piece here. Okay, and we know the entire bottom would be congruent to the entire bottom, but we already went through why this piece and this piece would be congruent as well, because we're adding on that same middle piece here, right? So we can conclude that those two pieces are congruent because we're just adding on, because I know the bottom DF, once again, DF is the second and third letter, so that'll be congruent to AC, the entire bottom. So AC is the entire bottom of this triangle. Okay, and DF, if I look at DF here, DF is here. It's made up of DC plus CF. Okay, and if I look at the bottom of the red triangle, AC, so AC is made up of AF and CF, so those two pieces, so AF and CF. So what you'll notice is, once again, you're adding the same, let's say these are congruent, you're adding the same CF to both sides. So if I subtract CF, we can in fact prove that just the pieces here are congruent. So you should know why. You don't have to go through why, but you should realize those two pieces are congruent. So I could set this half 4x minus 16 equal to the 6 up here. So this piece and this piece are congruent. The bottom of the red and the bottom, the big long side of the purple. Okay, so I can distribute the half here. So half of 4x is 2x, half of 16 would be 8. Okay, so to solve, I can add 8 to both sides. So I get 2x is equal to 14. Divide by 2, so x would be 7. Okay, so since the triangles are congruent by side angle side, I could set the two bottom pieces equal to each other. Okay, to solve for y, I'm going to clean up my diagram here. Okay, let me move this out of the way. So to solve for y, if I look at my diagram, we have two y's here. We have a y here. Okay, and unfortunately, that's this angle here, but unfortunately, it's not labeled in this diagram, so I can't set it equal to anything. But I do have a 38 degrees here for angle D. And if I look at my congruent statement, angle D, the third letter, so that would be congruent to C. Okay, so that means this would be 38 degrees as well. So angle C in the other triangle. Um, and then angle F is not labeled here, but in my congruent statement, F is the middle letter, so that'll be congruent to angle A, which is in fact labeled. So this would be 2y minus 26 as well. Okay, so we do have all three angles. So this angle, this angle, this angle. So I do know I could just add, I do know all three angles would have to add to 180. So the 38, the 5y, and the 2y minus 26. So those would all have to add to 180 for a triangle. Okay, so if I look at here, we have 5y plus 2y, so I can make that 7y. And we have 38 minus 26, which would give me a 12, so I can combine some like terms there. Okay, minus 12 on both sides, so I'll get 7y is equal to 168. Right, so then I could divide both sides by 7, so y would be equal to whatever 168 divided by 7 is. So if I go to the calculator here and I type in 168 divided by 7, our answer would be 24. All right, so that one's a little bit of work because if I just had like this B labeled, I could just have 5y equal to whatever that is to set the corresponding parts, but you had to use all three angles to solve for y there, but that would be my answer for that one. Okay, so the last part of the section is we're going to look at different proofs. So writing proofs for side angle side. Okay, so if I switch over here, and this PDF is posted on Canvas, so you can follow along or copy it later if you don't have a hard copy. But I already wrote the givens just to save some time in the video. But let's talk about how we can prove triangles congruent in a two-column format. Okay, so for the first one, I like keeping track on the side of um, my congruent statement. So remember, side angle side, I need two sides and an angle. So we always need three congruent statements. So three of these symbols congruent here. So I'm given two. So this is a side, a pair of sides, and this is a pair of sides. So we have two sides here. Okay, and you should always label it on the diagram as well, which they are. So uh, both of those pairs of sides are labeled. Okay, so I just need the included angle in order to use side angle side. So if I look at my diagram and we want to prove J and K, so J and K is this red triangle, is congruent. Let me color code this. So J and K is here, is congruent to M and L. So M and L is this blue triangle here. Okay, so if I look at my diagram, if I have this side and this side here, the included angle would be the ones in the middle. And you should notice here, we do have vertical angles, right? So J and K. So I could say angle J and K is congruent to angle M and L. Let me just neaten this up. M and L. Okay, and that's the vertical angles theorem, right? So vertical angles theorem will be good rather than writing VAT, but you could just write VAT. So we do have vertical angles here, and you'll notice in the diagram now we do have, so we have a congruent statement for angles, so label down the side. So now we have all three pieces we need. Okay, so we do have side, angle, side in my diagram. So with that single additional statement into our givens, now we have enough information to, I'm just going to copy down what we're trying to prove here. So J and K is congruent to triangle M and L. Okay, so that would be side, angle, side. And you could always abbreviate that. You don't need to write that full out. So if you're a VAT and SAS, abbreviations are perfectly fine there. Okay, so we just needed the vertical angles, one additional piece to get that proof done. Okay, looking at number two. Okay, if I look at my givens, we only have one congruent statement there, right? And these are segments. So this is a pair of sides. So we only have the one side here. So we're going to need two additional congruent statements for this proof. Okay, so if I look at my diagram, we have this side and this side. Okay, so that's the given. But what you'll notice is I'm also given that PQ bisects angle SPT. Okay, so SPT is this I highlighted it. So SPT is this big angle here in red. So it says PQ bisects it. So PQ is here. So remember, bisect, and it's labeled in the diagram, but bisect means it cuts it in half. So bisect means it makes two equal smaller pieces. So I can state that these two pieces, these angles here are congruent. So this is angle SPQ. So that would be congruent to angle TPQ. So this angle here, TPQ. Okay, so I could state that those two angles are congruent. And the reason I knew that is because it told me a bisect. So remember, bisect means it cuts it in half. So that'll be definition of, you could just write bisect here, but it's an angle bisector, right? So bisect or angle bisector. So that's what bisect means. It cuts it in half. Okay, so that's an angle. Okay, so if I keep track of what I have, so I have this side and the angle there. So for side angle side, I need the two sides that make up the angle. So we have this red side here. Okay, so if I'm looking at this angle is made up of this side as well, right? So what I also notice is with this side that I highlighted here, it's a shared side, right? So this side is in both the left and the right triangle. So I can state that PQ is congruent to itself. So that's going to be my reflexive property. So reflexive property of congruence. Okay, so now you'll notice we have three congruent statements. So we just stated another side. Wait, and I don't have to pay attention to order here because I could have wrote the reflexive property first and then the angle. So the order here doesn't matter because you could always switch the order and do the reflexive property first. But once I have all three and I check on your diagram, it is in fact the included angle. So we do have side angle side. We do have enough information to state that triangle SPQ is congruent to triangle TPQ. Okay, and this would be side angle side. So in this section, it's only going to be SAS, but like I said, once you have all five, you'll have to decide which one to use. Okay, let's look at just a couple more here because they're all slightly different. Okay, so if I look at the givens here, we do have just the one congruent statement, and these are sides, right? Not an angle. So we do have one. So we're going to need two more congruent statements in order to prove this one. So if I want to prove that ABC is this triangle is congruent to CDA, so CDA is this triangle here. Okay, and what I noticed right off the bat is that I know I did it separately, but they do have a shared side. So this middle one is in both red and blue. So the middle one, which would just be CA, is the shared side. So CA is congruent to CA. Okay, so that's the reflexive property of congruence. Okay, so that's another side. So it looks like we need an angle now. Okay, so if I look at what else, we have the congruent here, but we also were given this statement here. So BC and AD are that, remember, those lines mean parallel. And we do have the arrows on the diagram as well. So BC is the top one here, and AD is the bottom one here. So these are parallel, which means we have a transversal cutting right through the middle here, right? So if I look at the parallel lines here, it looks like we do have angles that are alternate interior here and here. Remember, I don't want to choose the ones on this side because between the transversal and the parallel line would be this entire angle, so it's not that this is being split. So if I look at these angles here, so angle BCA and angle DAC, so that angle there, so angle DAC, we can say that according to alternate interior angles theorem, those are in fact congruent. So we do have an angle. So it looks like we have all three pieces. I know it's not in the order we want here because we did the reflexive first, but if I look at my diagram, if I mark this shared side, you see this bottom one and the reflexive one, this is the included. We do have side angle side here. So we do have enough to state our ABC is congruent to triangle CDA. Just copying this down. So that'll be side angle side. Okay, I want to finish up with this one, so number four. And you notice in my givens, there's no congruent symbol at all. So we're going to need to come up with all three. Might need a little more room here ourselves. So let's go one given at a time. So it says B is the midpoint of AD. Okay, so AD is this entire bottom side here. Okay, so we have AD here. Okay, it says B is the midpoint. So if B is the midpoint, remember, midpoint means it divides it into two congruent segments. So this piece would be congruent to this piece. I'm drawing it separately to visualize it, but I can state that AB and BD, so these two pieces, AB and BD are congruent. Okay, so that's definition of midpoint, right? Midpoint means it makes two congruent parts. So there's a side. Okay, if I look at my next given, it tells me ABC and DBC are right angles. Okay, so that means these two are right angles, it's labeled. I remember we had a theorem that says if they're both 90, they're congruent, so all right angles are congruent. So I can state that ABC, I'll just keep the same order there. So ABC is congruent to DBC. Okay, so that's all right angles are congruent. Congruent. Okay, so we do have an angle there. So it looks like we need one more side. So if I look at my diagram, well, if I'm looking at this angle, we need the included. That has to be the included angle. So we have this bottom one here. So that means the other side of this angle will be this one. And if I look at the left and right, this is a shared side. So this middle one, CB, is shared. So either CB or I'll just go alphabetical. So BC is congruent to BC. So we do have the reflexive property again. So reflexive property of congruence. Okay, so now we have all three pieces we need. So our final statement can now be triangle ABC is congruent. I'm just copying this down to triangle TBC. Okay, and that would be, once again, side angle side. All right, so I do want to end off there. You could try 5 and 6. They're similar with parallel lines. You should have some angle relationships there. Um, yeah, so practice some more, but you could always go back and rewatch any pieces that you need with these proofs. It takes a little getting used to, but you'll be doing them with SSS with all the other shortcut theorems as well. Um, so practice with those proofs, and that is side angle side.